All right, so what happens if the a value is not a 1, okay? And there's no greatest common factor to pull out, okay? Then I want you to focus on something called the Berry method. A guy by the last name of Berry created this method, and it's almost going to look like two magic tricks happen. So I'm going to walk through this with you. Now, imagine picking up that 2 and multiplying it on the 4 at the end and rewriting this x squared minus 7x minus 8. X squared minus 7x minus 8. Now, the reason I put an arrow in between is because they're not equal. These are not equal to each other. Okay? But what I'm going to be doing is a process, and once we get done, we will have something that is equal to the original. Okay? But it looks like I kind of do some magic to it. And there is a very long proof, which we will not be looking at. But this does work every single time, and instead of me sitting there and having to guess and check and guess and check and guess and check, which is what they made me do when I was a kid, this goes straight to the answer. Very straightforward. I like it a lot. So let's factor this. Okay, so we've got x and x minus 8. That means we got a plus and a minus. We need things that multiply here and add up to here. That would be a minus 8 and a plus 1. Okay, so we did our basic factoring. Now, remember the 2 that disappeared at the beginning? So we have done basically step 1, step 2. Drop the squared on the quadratic and copy into each. I'm going to ignore the instructions over here. There is kind of an alternative way to look at it, but basically we're gonna get to the same place. So after we've moved the 2 down to the end, we are going to then bring the 2 back in front of both of the x's. Bring the 2 back, okay? Okay, that brings us down to like this step down here. Now, if you think about this, 2x times 2x, that's 4x squared. That's also proof that this is not equal to the original. Well, what you're going to find out is that there is a GCF that has been introduced that does not belong. So what you do is you focus your attention on each set of parentheses and you ask yourself, is there a greatest common factor inside of 2x plus 1? And the answer is no. But then you come over here to the 2x minus 8 and the answer is yes. Sometimes only one factor has a GCF. Sometimes both have a GCF. And so you've got to check both of them. I see that there's an extra 2 inside here. And so what we're going to do is we're going to pull that 2 out. And we are literally going to throw it away because we don't need it. So this is going to become x minus 4. And this stays exactly the way it was, 2x plus 1. And now, guess what? We have something that is equal to the original. It is the correct factored form for 2x squared minus 7x minus 4. So, we need to keep practicing this. Now, first off, no GCFs in the original. You gotta check that first. If there's a GCF, we gotta get it out before we ever try the Berry method. Okay? So when I look at these things, the first thing I'm gonna say, is there anything in common between 5x squared minus 13x and minus 6? No, nothing. So we can start on our process here. X squared minus 13x minus 30. I got x and x. A minus, so that's going to be a plus and a minus. Factors of 30, well, let's see here. We got 1 and 30. We got 2 and 15. We got 3 and 10. And we got 5 and 6. Now, I know you're going to be tempted to use 3 and 10 because you look at that and go, oh, 13. Here's the problem. This is another tricky one. Because you got 1 plus and 1 minus, the correct choice is 15 and 2. Because that's a minus 15 and plus 2, they add up to negative 13. So that's a trickier one. Okay, now the 5 that disappeared at the beginning reappears in front of both x's. Reappears in front of both x's. And now we're asking ourselves, GCF? Nope. GCF? Yes. Take the 5 out, leaving me x minus 3 and 5x plus 2. And that is the correct factorization of the original. Try again. Okay, first off, no GCFs. You know, at first you're going to be like, oh, 3 goes into those two, but it doesn't go into the last one. So no GCF. And so we can immediately take the 9 times the 4, giving me x squared plus 12x plus 36. And, oops, x plus, and it looks like factors of 36, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Dang, there's a lot of them. 6 and 6 does look like the message of choice there. And then, of course, the 9 comes back in front of both of the x's. And we look for a GCF. Oh, it looks like there's a greatest common factor for both of these. They both have a 3 that we can pull out. And if I pull it out of the first one, I get 3x plus 2. If I pull it out of the second one, I get the same thing. And in a previous example, we said if you had the same thing twice, you could write it like that. And I know it's the same as the one above it, but you got to get used to something squared, because that's going to come up later in different problems. Okay, no, there's nothing that goes into 3x squared minus 22x and positive 7. So once again, let's do this. X squared minus 22x plus 21. Factor it normally. X minus, right? They both have to multiply to a positive, but add up to a negative. And of course, the only thing we got 1 and 21, or 3 and 7. The only thing that adds up to 22 would be 1 and 21. Then, of course, we bring back the 3 that was in front of both of the x's and look for greatest common factors. Nothing in the first one, 3 in the second one. So 3x minus 1 and x minus 7. And there's your factorization of the question. Okay, no GCF. Always got to check that. So now we're going to multiply and get x squared plus 7x minus 18. And now we're looking for, okay, with a minus there, that means we're going to have a plus and a minus. And then we'll take a look at our factors, which of 18, we got 1 and 18, we got 2 and 9, we got 3 and 6. Well, it looks like the winner is going to be 2 and 9. We have to have a 9, which is positive, and a 2, which is negative, so that we get back to 7. Now the 6 reappears in front of both of the x's. And now we're looking and saying, oh, there's a GCF in the first one, right? 3. So if I take that 3 out, I get 2x plus 3. And in the second one, I have a 2 I can take out, which would be 3x minus, not 2, 1. That is your factorization of the original. Berry method comes in very handy, very straightforward. Like I said, always look for a greatest common factor. So what do they all have in common? Well, I at least know 2 goes into them. 2 goes into 70 35 times. I don't think anything else does. So I'm going to take a 2 out of each one of these. So that's going to leave me with 2, 4x squared minus 4x, and a minus 35. Okay, so I don't think anything else goes into all of them. So now it's time for me to take the 4 times the 35. And my final answer is going to have 2, and then it's going to have 2 parentheses when I get done with this question. Okay? So that 2 that's out there in front, that has to be in my final answer. But let me do my work inside the parentheses over here on the side. X squared minus 4x. 70 times 2 would be minus 140. Okay, so 140. We got 1 and 140. 2 and 70. 5 goes in how many times? 228. Ooh, I forgot 4. 4 went in how many times? 4 goes into that 3 times. 35 times. Yeah, well, that makes sense. I just did 4 times 35. Duh. Okay. 6 does not go in. 7 does go in 20 times. 10 goes in 14 times. I think that's about it. I don't think there's anything else that goes in. No, that's it. Okay, so now you're looking for things, and I think it's going to be this 10-14 combo down here, because you're going to have x minus 14 and x minus or plus 10 to get back to negative 4. And then, of course, now we're going to pull out the, we're going to put the magic 4 that disappeared is going to now reappear. 4x minus 14, 4x plus 10. And we're going to look for the GCFs. I see a GCF of 2 that I can pull out of that one, which would leave me with 2x minus 7. And I can see a 2 that I can pull out of that one, which would give me 2x plus 5. There's my final answer. Not forgetting the original 2 that we pulled out at the very beginning. So, little perfect square trinomial. Well, that title goes with the next slide. I guarantee it. Perfect square trinomial. Okay. Oh, let's see here. It's going to look very similar to what we've done before. They both have to be the same, and they both have to be negatives. And the things like 1 and 49 or 7 and 7. 7 and 7 is the only combo that gives me negative 14, right? But the point they're trying to make is that it's something squared. That's what they're trying to get at. This is called a perfect square trinomial. And what you can see is that if you take the middle term and you cut it in half, right? If you take this and you cut it in half, you get 8. What happens when you take that number and you square it? You get the end, you get the constant at the end. If that can be done, right? Like for instance, with this first one over here, negative 7. And if we take negative 7 and we square it, do we get the last term, the constant term at the end? We do. So what that means to me is that this is going to be x plus 8 quantity squared for the second. If you can see that pattern show up, now it doesn't mean that you can't do what we've done before. You can't sit there and go x, okay, I got an x, got 1 plus, 1 plus, factors of 64 that add up to 16, 8 and 8. And then once you realize they're both the same, then change it to this. There's nothing wrong with that. Now, you may not recognize this one being a perfect square because it's a little bit more complicated. Yeah, you probably don't recognize it right away. There's no greatest common factor that goes into all 3 of them. So, you might sit there and go, well, I should use the Berry method. there's no greatest common factor to pull out, so I'll just do this. X squared minus 20x plus 100. Well, guess what? That pattern just showed up again. What do you mean, Mr. Stailey? Well, what's half of negative 20? Negative 10. And what happens when you take negative 10 and square it? 100. So the perfect square trinomial strikes again. And of course, if we're going to have x and x and minus and 10 and 10. And then the 4 that disappeared at the beginning is going to come back. And then we're going to look for what GCF do we have in this one? What do we have in this one? Of course, you can take a 2 out of each and you get 2x minus 5 and 2x minus 5. And those are both the same, so that's 2x minus 5 quantities squared. Now, what is the relationship? If you recognize it is a perfect square, what's the relationship? Whoa, it looks like a square root of 4x squared. What's the relationship here? Oh, it looks like the square root of 25. And the sign in the middle goes with the middle term. Well, there's something to think about. If you can see that kind of pattern, it helps. But obviously the Berry method takes care of it. So if you're not comfortable with seeing that pattern, maybe it doesn't jump off the page at you, then just do the Berry method. You'll be completely fine. Let's see what else we got. And that's all for this lesson. See you later.